Okay, so hello everyone. This is the workshop session. We have two workshops, and Fraser Lewis will be our chairperson. So, Fraser, if you want to introduce our first speakers, please.
Yeah, sure, Gustavo. Thank you. So, our first workshop today is going to be looking at Zero Shadow Day for tropical countries. And it's going to be led by Samir, Sonal, and Alok. And I just need to check if Samir is now with us.
I think he's not here yet, but maybe if Sonal and Alok want to just say something while. Oh, Samir is joining. He's entering. But if you just want to say hello.
Okay, so yeah, I think Samir had discussed this. So what we can try later on in the workshop is that have a separate breakout room for participants who are not from India. So me and Sonal can discuss India-specific activities for Zero Shadow Day once a significant part of our discussion is over, and Samir can then take participants from outside India in a breakout session and discuss there.
Okay, so is Samir here?
He's here, he's muted and...
Yeah, he is on the list at the top, so he's probably just still setting up his microphone maybe. Samir, do you hear us at all?
Yes, yeah, I'll just be looking at some problem with my camera. I'll just be there in a minute.
Okay, Samir, just one quick question. When exactly is the breakout session is going to be in the today?
It'll be towards the, we were hoping it to be towards the end of the...
Okay, towards the end. Yeah, because I need to leave for 20 minutes. But I'll be back to make the breakout room.
Please,
in any case,
that's so nice.
Okay, Aviva can also help you if needed. But
oh, Aviva's there. Okay.
Yeah.
Hi, Aviva.
So please, you can start.
Alok and Sonal, please go ahead and be the host. I'm probably unable to do that very well today. Thanks.
Hello, Samir.
Alok and Sonal, please go ahead and be the host. I don't think I'm able to do that well today.
Oh, okay. So,
thanks.
Sonal, do you have the first part PPT or something?
Yeah, just a
PPT. PPT I will have just to make the people feel welcome here.
Yes, not a problem. I'll do that. I welcome you all on behalf of IUCA and let us. We are going to talk about the activity or event known as Zero Shadow Day, which is celebrated in tropical regions. So between 23.5 north and 23.5 south latitudes, everywhere this event is observed. And we are going to get to know how what we can observe on this day and how the shadows disappear or become minimal. As we all know, we can see shadows whenever it's a bright sunny day or whenever you are under a bright light source. So we are going to know how to have fun with these shadows and sources of light. And Samir is going to tell us about the basics and geography about the event. And then we will also learn about some simple activities using which we can teach how shadows and movements of sources are related and what we can learn from them using do-it-yourself hands-on activities from the material which is laying around us. And then Alok is going to tell us about the web resources as well as some tools, applications which we can use to find out the Zero Shadow Day at the places in tropical regions, as well as some other interactive animations he is going to show us. And then at the end, we will be discussing about how we can arrange large-scale activities which can involve or engage public, even during the pandemic. So I welcome Samir here, and I'll request him to start the session.
Thank you, Sonal, and thanks, Alok. Yeah, I am really sorry here because of for my voice and in general my slightly distracted presence. So just yesterday, I got diagnosed with COVID. So I'm here at home in a quarantine, and will try to do my best for this workshop. However, you should please feel very welcome in this workshop. And there is this special event which we have been taking a lot of efforts to publicize all over the world, especially to all our friends who are in the tropical countries. These are the friends that we want to basically get together and do this lovely activity. And I will very, very soon I'll come to the details of it, and also tell you how easy it is to do it and how low cost it is. But then it also is very effective. So this is from our work which we have done in India. So we'll present that as well. What you might have already seen in the lineup of the workshop is that after we present the event itself and a few activities that we do and a few web resources which our expert Alok has nicely designed, which can be used anywhere in the world, including a website and an app. We will then actually put our brains together to think of what we can plan up for your particular case in your region, or if in your country, I mean to say, or if there's a region like like Southeast Asia or Caribbean or something like that, then we can also at least exchange contacts, or maybe lay down the basis of a future collaboration in these regions for Zero Shadow Day. So if it appeals to you, I hope we will all be better friends and join together to take this up next year or next season, because it happens all the time throughout the year in the tropics. So let's get down to the main thing, and I'll start sharing my screen with a short presentation. Okay, so somebody please acknowledge if you can see the screen properly.
Yeah, it's visible.
Okay, cool. Thanks so much. And thanks for all your wishes in the chat. So, so the title of our workshop is Zero Shadow Day for the Tropics. And I hope, if nothing, the name Zero Shadow Day itself might have drawn you to the workshop to see what is this happening? Why? What is a Zero Shadow Day? Where is the zero shadow coming from, right? Or where is the shadow going, basically? So, yeah, I mean, I always start with this lovely quote from Sylvia Plath, that one of the most beautiful things, one of the very curious things in the world is a shadow. Okay. But then sometimes we realize that no, shadows are also a lot of fun. And that's what this activity is all about. We can see here that there's this piece of pipe, PVC pipe, or any kind of cylinder which you put down in a ground at around noontime, and you see that its shadow is gone. And I'm sure you'll be wondering, where has it gone? What happened here? The sun is shining. Where is the shadow gone? Okay. So that's the catch phrase for us, and we kind of sometimes get questions like, why are you calling it zero shadow? Why not minimum shadow day? But you see, we caught your attention. So that's one of the trade secrets of public communication, that first attract the attention, then you can talk with them about anything. So of course, it's not as bad as the clickbait headlines in these days media. But well, let's see. So so that kind of lack of a shadow is fun, but it is also useful. And you might remember, or you may not have related it, but Mr. Eratosthenes in Alexandria had also used it about 2000 years ago to find a very special measure. This was the circumference of the earth, found by using the fact that one of his friends in a place called Syene in what is Egypt now, and you probably used to be Greece or Alexander's kingdom at that time. So at one of those places, the sun would on some days, or actually on June 21st, be in at such a position at noon that there would be no shadow of a well's border, of a well's wall inside the well, right? So his friend had told him about this curious aspect. He said, okay, let me see what happens at my place in Alexandria, where he was the librarian of a great collection of literature of that time. Right? So he went ahead and on the same day saw the shadow. He didn't have a well, and maybe the pole was a better thing to see. So he looked at the shadow of a pole, and it did have a shadow. Okay, a slightly small shadow at noontime, but it was there. And we're talking about local noon. So both of them knew about this concept of local noon, and they saw that when at one place you did not have a shadow, at another place on the same earth that we live on, there was a shadow for a certain object. So this was very curious, and people kind of might have seen it before, but Eratosthenes thought, okay, this is one of the proofs that the earth is round. Okay, and we are not talking about people who still believe that the earth is flat. 2000 years ago, we had proved that the earth is round, and we even found the circumference up to, the circumference was found up to, I think, an accuracy of 80 kilometers or so. That was an amazing kind of achievement. And there are actually Eratosthenes experiments can be repeated even now. Okay. And you can actually do this kind of an experiment with students in your surrounding, or students or anybody, in fact, to get them interested in such events of happening. Of course, for Eratosthenes experiment, you don't always need to have a zero shadow. You can just do it at any other place, and with a basic knowledge of geometry and basic knowledge of what is a local noon, you can always find out the circumference of the earth. But I was just pointing out that Eratosthenes also used the fact that his friend had zero shadow on a particular day. Okay, so yeah, that and that happens to be a case. Oh, sorry, I'll just come back to this. So, but Eratosthenes himself never had zero shadows in Alexandria, because his friend was to the south of it in Syene, what is called Aswan right now. And that was the last place towards the north, that is the northernmost limit of having zero shadows. Okay, so that so Aswan or Syene is actually on the Tropic of Cancer. So he might have never seen the zero shadow happening. But places like here in India, for example, people here are crazy about cricket. And of course, there are many other countries in our region of the tropics where people are also crazy about sports and cricket especially. So you can see in this particular picture that the players in the ground don't seem to have shadows, right? So that's a very good example of the shadows disappearing in a popular event which is happening. Okay, so these people are practicing cricket. So similarly, another picture with minimum shadows. Okay, so of course, if you look closely, you zoom in, people do not lose their shadows completely. They don't disappear. They are there, but they are very minimum, and they are at our feet. However, if you are a cylinder, then you will lose your shadow completely, because your base will be covering your shadow at mid-noon. Now, I'll repeat that this is not something very new. This has been known to people for a long time. In fact, in the Hawaii Islands also, there's a celebration of this called the Lahaina Noon, which has been going on for about 2-3 decades now. And a lot of science popularizers there are also using this same event to publicize, solar motions in the sky, motions of the sun in the sky, and their relation with geography, etc., etc. So this is basically what we are going to highlight in the Zero Shadow Day. What we are saying here is that, is the presentation still visible? Okay. So, okay. Right, sorry, I'm using Prezi and okay. So what is this due to? We'll look at a quick basics kind of look at it. So usually we say that when the sun rises in the east, and we know that it travels and goes to the west, and averaging out every kind of change due to seasons, we can say that the sun is overhead at noon. This is the general thing we always talk about in a geography class, or have learned in a geography class. So sun is overhead at 12 noon. However, there are many factors by which this does not happen. And the biggest one being that, it also contributes to the time zones across the world. So the earth is round, and your country is, of course, spread across a few different longitudes. And so you will never have, one part of your country having the sun overhead, and the other part with the other part also having it overhead. That will never happen. There will be some difference. Therefore, local noon is when the sun is on your meridian. The line joining the North Pole and the South Pole of the sky is called the meridian. And that's when the sun crosses that meridian, or sun is crossing or is on that meridian, that is when local noon happens. Okay. In fact, the names AM, PM come from that anti-meridian and post-meridian. So, so the thing is that we are also aware of another reason why the sun is not always overhead, and that is because the Earth's inclination in this, the Earth's axis is inclined to its plane of orbit by about 23.5 degrees, and because of that, we are always seeing the sun either moving towards the north or the south in the sky. Okay. In India, in fact, we have a name for it called Uttarayan and Dakshinayan. So this basically means the northward movement of the sun and the southward movement of the sun. Of course, in ancient times, we used to give a lot of importance to that, and we still have festivals celebrating it. But the scientific reason for this is basically because the Earth's axis always points in one particular direction. We can have, so since the Earth's axis is always pointing in the particular direction while it goes around the sun, okay, this is very important. And sometimes, even the even the most accustomed communicators miss this fact, that the Earth's axis, although tilted, is always pointing in one direction over, let's say, a few years at least. And that's why the North Star remains always in the north, right? Otherwise, if it was just turning around all the time, it would not happen. Okay, so over a short period of time, at least over many years, the Earth's axis points in this direction. And because of that, the inclination of the Earth towards the sun changes. So you see, during what we call summer in the northern hemisphere, the pole is more inclining towards the sun. During what we call the winter in the northern hemisphere, the southern hemisphere is more inclined towards the sun. Okay, and because of that, what we perceive from the Earth is a motion of the sun in the sky. So So this is what we are basically seeing, that in the winter skies, the sun moves relatively to the south. This is a view from the northern hemisphere, or people in the northern hemisphere. Then around equinox, the sun would kind of move in between these two extremes. And on the June 21st, the sun's path would be somewhat like this, very much towards the north. Okay. And so if you're at the equator, in this case, what you would see is that on winter solstice, the sun would be going about 23.5 degrees away from the zenith, okay, at noontime. It would be 23.5 degrees away from the zenith at noontime. And on the summer solstice, it would be 23.5 degrees away towards the north at noontime. It would also not rise exactly the east. It would rise slightly northeast and set slightly northwest. If you look at that degree also from the exact west, that would also come out to be 23.5 degrees. And you see, immediately you can actually point out a way to find out what is the inclination of the axis of the Earth. Because maybe we can ask this question: how did we come to know that the Earth's axis is tilted? Right? This seems to be known quite a while back, even before satellites were there, and we went out to take few pictures of the Earth or whatever. I mean, so how did we come to know that the Earth's axis is tilted? Is the question, is the answer in here? Have a look. So see, you can put in so many different things, aspects of astronomy, geography, and even include simple things like the north and south motion of the sun in your zero shadow day activity. Now, what we are going into now is the shadow. Okay, so when the sun is either in the north or the south, you see the shadow of any object, let's say vertical object, would be towards the longer or shorter side. Okay, so it would either be long or short. Now, and then this is okay for all hemispheres. So you can see it is this is the Table Mountain for South Africa. So it also works there. But zero shadow day will not happen in all countries. It will happen only in countries where the sun can come overhead at least on one day. At least, I'm saying. Okay. And what will happen is on that day, the sun would be climbing further higher up than this. Okay. And at least on one day, it would be in a way at local noon that it will be, its light would be perpendicular to this object. Therefore, the shadow will be at the base of this object. So that's what zero shadow day will be all about. So now coming back to this, let's say you're at the equator, okay, and then we those of us who are in the northern hemisphere and southern hemisphere can quickly look at what our placings are, and then find out what the further details. So if you are at the equator, let's say, okay, so you see that the sun will move, let's say, from the winter solstice day, it will slowly move towards the north, and on equinox, okay, it will be overhead or at local noon, overhead, exactly right on top of you. So if you're a cylinder, you'll lose your shadow. If you're a human being, you'll have a small shadow. If you're a tree, you'll have a bigger shadow, but minimum, the least that will be there throughout the year. Okay, so you can look at any other objects with their shadows becoming minimum. Then the sun moves towards the north, summer solstice happens, and then it moves back south. And again, on the next equinox day, you see the sun will be overhead, and you'll again have a zero shadow day. So you see immediately that there can be 2 zero shadow days for equator. Okay. However, suppose you're not at the equator. Okay. So the sun would move 23.5 degrees this direction, and it will move more than 23.5 degrees this direction if you're to the north of the equator. Okay. So what will happen is the sun will keep moving like this, and you will be at a place somewhere in between these, let's say. Okay, so more towards the north. So what will happen is the sun will come overhead on 2 days, but not on the equinox. It will be a day after the equinox and between the solstice. Okay, now you will ask me, what are these days? So we have a web resource to actually find out which days are those when you get a zero shadow day at your own place. Okay, so and same applies to the people in the southern hemisphere. So they will have the people between the equator and 23.5 degrees south latitude will have their zero shadow days between these 2 days, the vernal equinox and the sorry, what we call the winter solstice. In case this is just a naming convention. So so these are important days, and you can just find out your own day, and you have the whole year to plan out when you're going to do your event of the zero shadow day. Okay, and what are the it's a great outreach activity, and I want to just show you a few pictures of it. Okay, so you can see this activity we have been publicizing in India, and it's great fun. You can see that during this was in 2018, I suppose, when COVID wasn't affecting us, but even then you can have a socially distanced nice activity. And even this year we've done several activities here in which people have socially distanced, and they just need to go to a ground and see their shadow disappearing if they want. This is also a great outreach activity for teachers. So you can see some geography teachers actually taking students outside. They're sitting in a shade of a tree. But basically they can talk about geography, they can talk about the roundness of the earth, they can talk about seasons, etc. And the reason for seasons is actually also causing the zero shadow day. Okay, so that's another way of using the zero shadow day for your advantage. A few more pictures of people enjoying zero shadow day and in doing several activities. They found various shapes and objects to find zero shadows for. Let me see. Yeah, and this is actually the IAU's executive committee also enjoying the zero shadow day at our place in Ayuka. Last pictures. Yes. Then other than that, we've also had like big public events which were not even done by astronomers. You just have to be a science communicator, and you can use it for various reasons, various purposes. So people put out various things like this. They even put out telescopes. They put out clocks to see what is the local noon, right? They put out fruits and vegetables to see what kind of what time the zero shadow happens, and does it also happen to vegetables? Of course it does. So that was a lot of fun. Now, quick look at the zero shadow days. So we've been using this particular event for a lot of activities in India specifically. So we've got several good teaching resources. Some tools have been developed. We've had, this is for a while back. I'm sorry, since I'm quarantined, I couldn't get to my computer, which has the most latest data. But there have been several regional workshops, state level workshops, and more than, in that year, more than 75 large scale public events happened. So that's a really big, and a very popular event. Even the media was very supportive of this. And the only basic things that you need to have is the sun shining overhead. That's all. You can, of course, you can go into detailed things like, putting out a glass slab and having various kinds of shapes. You can have a clock outside. You can make something very, very simple, but very effective like this, where there's a cardboard with sun written cut out of it. Two of them kept perpendicular, and this SUN appears best only at the zero shadow day moment. So such things can be, devised, and you can have fun with that. Now, for this particular workshop, I would like to stress that there is a world of zero shadows. That's what I call it. So you see, if you are in between these, this dark, slightly dark shaded area, and you can probably see yourself here, or you can see some of your friends' locations here. These are the places you can very easily use zero shadow day effectively to reach people without spending anything. That's one of the very important things. There's hardly any spending. You just have to probably spend your time to get people to know this, right? And the media simply laps up this event, and they love such exciting events happening. But there's so much more to talk about through this event, and that's why I appeal to you that if you are within this shadow band or zero shadow band, please go ahead and celebrate Zero Shadows. Okay, and there's also a lot of different things to learn from this. Especially if there are friends here from the Asia Pacific region, this because we are here close by and in time zones which are not too far apart, we can actually look at doing something collaboratively across the longitudes. Okay, so I showed this picture, and you'll ask me, how do I find out which time my Zero Shadow Day will happen? So for that, we have resources. We have a few resources, and this picture, this screenshot was actually taken from a website that we've already put up. Alok is its creator, and it is an interactive website where you can actually click at your own place or any other place and immediately find out where the Zero Shadow Day is. But Alok is going to talk about that. So I think I'm going to just end with a quick flash and appeal to join hands for this. We are, of course, doing this, and it's extremely popular in India. Because of that, I think we should share it with the whole world. And anywhere you are, either you can use Eratosthenes method to popularize these things, or and also talk about Zero Shadow Day. Or if you are actually celebrating Zero Shadow Day, you can use any of the resources at this website we have given here. Alok will be making you acquainted with more resources in his presentation. So, thank you very much. I can see a lot of some chats, but let's go ahead with some of the web resources. Maybe if you can slightly, shift the order, and Alok can go for the web resources first, then Sonal will talk about the activities. Is that okay?
Yeah.
That would be okay.
Thanks.
Okay. So I'll share with you some of the resources that you can use for planning and organizing these sort of events. Let me share my screen. Okay. Is the PPT on?
Yes.
Okay, sure. So, so as Samir went through so many concepts that can be covered in any outreach activities. So not only just Zero Shadow, you can explain basics of geography and basics of data measurement, so many concepts that can be explained while organizing this activity. So I'll just go through the resources that we have compiled, and you'll see that they'll be very handy in explaining these concepts like solstices, equinoxes, how the day lengths are changing, how the seasons are varying, etc. Okay, so this is the basic utility that we started with. And so initially, when in India we observed Zero Shadow Day, there was a table that outreach people here compiled that, for example, in so and so city, this is the date. But I thought that why not just do that calculation on the fly? So this is the web utility that you can go to right now. Let me, yeah. So this is the website, alokm.com/zsd.html. So this is a web-based thing. It would be opened by any device, any browser. So say for suppose I want to go to this Singapore area, and what I'll do is just double click on Singapore. So a pop-up will come that will show me two Zero Shadow Days. First will be on 23rd March, second will be on 19th September. So the time right now is shown is IST, but it will also tell you when the shadow will disappear. As Samir explained, that will be only at the time of local noon for that particular place. Okay, so other than the date and time of the Zero Shadow, this is also, if you see there is a vertical line from that location selected. That basically is a line showing the distance from the equator So this distance is something, if you, right now you see many groups that are doing the Eratosthenes experiment. And if you collaborate multiple groups from different locations on Earth, so this distance would be important, because two readings from any two different places would need this. I'll not go deep into this, but these are the info that you will get when you use this. For example, say now I go to North, say I go to Europe. What happens if I double click there? So as you can see, the zero shadow day would be observed only in the tropics. So it clearly shows that no zero shadow day can be observed here, but the minimum shadow you can observe is on summer solstice, 21st June. So the shadow is not zero, but it would be minimums on summer solstice. So this is the basic this was the basic web utility that you can use right now. But what we did was we compiled a lot of visualizations and made an Android app out of it. So if you have an Android phone, I would urge you to download this ZSD app. You can search for it in Google Play Store. This is the icon, and Zero Shadow Day, and you can install it right now. And there are many sections in it that I'll just go through quickly, and you can play around with it. Better to do it hands-on. So first of all, it's multilingual. For international languages, we have had many contributors. I think Spanish and Portuguese is supported right now. And in regional languages, more than 5 or 6 languages are incorporated. So yeah, so when you open up the app, the same web-like interface is also available there, where you can just click around on the map and find out the data for any location. That is one section called ZSD Finder. Then, for instance, you would also need to, other than the zero shadow, you would want to see how the local noon time is varying for the year. So basically, if you see, there are two components that it is a conception that the noon time is 12. But if you, what happens is that nowadays we are following standard meridians for the country you are in. So for India, it is Allahabad, 82.5 degrees. So all the countries following a single time zone. So that's why the local noon time is different from what your clock is showing. So one part is that. The other is, you can see that there is something called equation of time. So that changes throughout the year. That is also something you can check out and see how it is varying throughout the year. So that is also a dynamic thing that that has a section in the app. And this is a shadow length section. So this would be a ready reckoner. So one of the activities that you can plan out, even without having zero shadow days, asking the students or anyone interested to take readings of the shadow lengths for a given time throughout the year. So he can see how the altitude of the sun is changing throughout the year. And this is just a graph for that. And it's sort of a ready reckoner. So if you want to double check or see how that variation takes place for any given location, you can just change the time, date, place, many things you can change and get an idea and explain many concepts using this also. So this is one more section. Now this one is a 3D representation, the illustrations that Samir showed. So this is like a 3D real interactive version of that representation. This one is an image, but if you try it on your own mobile, you can swipe around and see it in from any perspective. So hello. Yeah, so you can see it from any direction, change the date slider, change the time slider, and see how the shadow of this gnomon is moving around. So this is a completely interactive 3D thing that just will give you how exactly that shadow moves around throughout the year. So there are a few other interactive animations as well, like this, how the equation of time is changing and NLMI, etc. So a bit advanced concepts, but if you want, you can go into these as well. So like I showed the web utility first, right? So there are other web visualizations that we can find out. So for example, this one is 1 year around the sun. So I'll just open this website and okay, so now you can see it is starting from 25th August. So this is how the Earth is positioned right now. The sun in the middle, on the left-hand side, if you can see the cursor, the Earth will always be tilted towards the right-hand side. And if I change the date slider, I'm using my mouse simply just to change the date, you can see how the Earth is going around. And on the right-hand side, you can see how the light is sun rays are falling on the a meridian of any location, and this brown line on the right hand side is showing where the zero shadow day is. So there are many other such animations that you can see and play around with to find out how this is changing. Let me just close this one. Yeah, so as Samir mentioned that this zero shadow day, basically the zero shadow moment, the local noon time, is also known as Lahaina noon in Hawaii. It's also called, that location is called subsolar point. So basically it is, if you join the earth and the sun, that line is basically crossing the surface of the earth. That point is where we observe the zero shadow moment. Okay, so a couple of interesting things to note. That point where there is zero shadow moment at that instant, that is nearest to the sun. So you can imagine we have two, basically Earth and the sun. So this point is nearest to the sun, not by much, but still that's why it is basically having zero shadow. Another one is all the shadows on the Earth. So it's a very big claim, but all the shadows on the Earth are pointing to the place where it is zero shadow moment right now. So for example, if you go out and see any shadow, take a line from the tip of the shadow to the object, that is pointing towards where zero shadow is right now. So this I came to know a very interesting thing. I think in Islamic culture, this has been used a lot. So this is called Qibla observation by shadows. So when, as the prayers are to be, for Islam, the prayers have to be pointing towards Mecca. So when zero shadow day is observed at Mecca, all the places they have to do is just observe the shadow of any pole, and that shadow will be pointing to Mecca. And this is true for any location, but it's especially useful for Islamic culture. Okay, so another one. So how does this zero shadow moment that moves around? Okay, so we found out the days for different locations. So this utility, you can see there are two sliders. One is the date, the other is the time. Okay, and this is where the zero shadow moment is added. I can slide around, change the time, and see. Let me just zoom out. So you can see the day and night curvature clearly here. Let me just start this sunnier path. So what happens is, this is how the zero shadow moment is moving around. Let me just zoom in. You can see it's basically making a spiral sort of a thing. The time is increasing linearly. Let me just stop, clear it, and do the NLMA thing. So as you would know, NLMA is something, if you take the sun's position at fixed time every day, we get an NLMA. So I'll just set this NLMA thing. So 7 UTC. This is how the sun is moving throughout the year. So and this NLMA shape is basically of zero shadow moment, and basically it's a locus of subsolar point. So all this may be complicated, but these are some of the resources that you can play around with and maybe use as a outreach activity. And there are compilation of other resources as well at astronomy ASI POAC website. I think Sonal will go into some of the activities, that physical activities that you can do to demonstrate. So I'll just take you there. Thank you.
Thank you, Alok. So let us, as we have learned about the basics of what zero shadow movement is, and how we celebrate this event in India, and how we can use this particular event to learn about seasons as well as movements of the sun in the sky, the apparent movement of the sun in the sky. So we have learned about these in these 2 sessions, as Samir and Alok mentioned. We also saw how we can use the web-based applications, Android applications, to find out that minimum shadow day at your place. Now, I'm going to tell you about a few DIY activities. So let me start sharing my screen. So if you can see the screen, you can see that we had asked about a material which is very simple to gather. It's just some straight and long object. Just a moment. Yeah. So can you see my screen now? Yeah. So thank you. So material we require is just some straight long object, like you can see, if you can see here, I have a piece of a PVC pipe or a pencil, then a small ball of Play-Doh or real dough. I could not find Play-Doh, so I had a ball with me. Then a few sheets of blank paper and pen to mark the shadows. Okay, and marking shadows is again a fun activity, and I'll show you some pictures how people enjoy marking shadows and what they actually do of those observations. Then some household objects of various shapes. It can be anything, like I have a water bottle around me. So I have a water bottle, then I have some cylindrical object. It's actually a magnetic compass. So you can use anything. Then earth globe if possible, if not, it's okay. And a torch. Then a torch is to simulate the activity which we can observe on a sunny day. Okay, so if there is no sun, if weather is cloudy, it may happen many times in the tropical regions that during monsoon season, we cannot get clear skies, and that time we may not get to observe the zero shadow days or even the shadows because it is overcasted. So we can always simulate what is happening up there in the sky using the flashlight. And of course, we learned about the application. So these are the material required. Let me show you how we are going to perform the activities. So these are very simple shadow related activities I am going to show you. So let us start. So this is a picture of whatever I just told you, the list which is given to us. And the spirit level is used to check the level, of course, of the ground, because if the object is tilted, you know that even if the sun comes overhead, right, and the object is tilted, it is going to cast some shadow because of its own tilt, because it's not exactly perpendicular to the ground. So spirit level can be used, or even in Android, there are applications where you can check the level of the ground. Okay, so those can also be used. So this is just a picture of all the material. You can see tape, double-sided tape over there, which I used to stick the pipe to the board. Now, let me show you what we do with this material. So we are just going to simulate how shadows move. So what we can teach students inside the classroom, not only students, we can also play with these at home ourselves individually. Like many of us, I mean, I used to do it while I was kid. I still like to do it, making some hand gestures in front of a light source and seeing the shadows on the wall, right? So it makes a deer or a dog like that. So this is a fun activity, and we learn a lot actually about these, how shadows are formed, when shadows get bigger, when shadows get smaller. So this we all have done since our childhood, and here what we are going to do is we are going to use the same thing, the same light and shadow play, to understand the optics, or what we can call it as the astronomy and geography. Okay, so let me play this video for you. Here what we have done is just the light source is moving from one direction to other. And what we can see over here is, let us consider that light source, or I have used this torch. Okay, so this torch is over here I have used, and as the torch is going to move above the object, so you can see the shadow cast of the object, okay, on the surface. So I have just taken a video of this. I have put this, stick this pipe using a double-sided tape on a board, and I have kept a ball on it so that the shadow gets accurate and you can actually mark the shadow. So let us see it again. Consider the torch as the sun, and the sun is going to move from east towards west, okay, passing from your meridian. So let us see again how the shadows are going to move. So as the sun goes from east to west, you can see the shadow is getting casted and is moving from west to east on the surface. I'll play it again. So here we can actually teach as well as we can learn. We can see that shadow of an obstacle always move or always is casted in the direction opposite that of the light source, and it moves in the direction opposite as the direction of the light source. So this is the basic thing which we can teach simply by using a flashlight. You can even use a mobile torch, and any obstacle, you can use anything. Okay, so we can simulate actual movement of the sun in the sky. Now let me show you the next video. So we were learning about zero shadow day and the activities around. So here is a short time lapse of zero shadow day at Ayuka, which was taken 2 years back on 14th May. 14th May is the zero shadow day at Pune. So we observed zero shadow day at this latitude on 14th May. So I'm showing you just a time lapse, and here you will get to see what different kinds of object we can actually use to observe the shadows they are forming. So I'll play this once again for you, and you can observe how the shadow of two pipes. Okay, here you can see that one smaller pipe is kept inside a larger pipe. Okay, so when the sun moves from east towards west, as it passes over through the zenith, okay, as it passes through the zenith, you can see the least shadow of these two cylinders casted on the ground as two circles, so concentric circles you can see. So let me play this again for you. And what we have done here is to see these shadows clearly. We have just made a base and we have put a blank plain glass slate, and on that glass we have kept the objects so that we can see the shadows on the ground. So this can also be done if you do not have plain glass slate. What you can do is you can try to check the glass which is in your fridge. I have done that myself while performing experiments, and it works well too. So we just need to find out the resources which are available at our home and which doesn't cost anything. So you can just take those resources lying around and use this to observe how the shadows move, how their shapes change according to the movement of the sun in the sky. So this is zero shadow day at Ayuka, but we know that zero shadow day doesn't occur everywhere, right? It only occurs between the tropics of Cancer and Capricorn. So what else we can learn, or what else we can do using the flashlight? I can see someone is trying to cast shadows. Bianca, yes, that's really good. So you can try it on yourselves, that you just take any object and try casting the shadows on any screen. So here, what we are going to observe is what happens when objects are at different latitudes. Like we learned about Eratosthenes' experiment. So he came to know about this Alexandria and Syme places, what happens to the shadows of well and a pole on these two places. And then he performed an experiment to find out the circumference of the earth, etc. So that was a really fun experiment, and we can perform that experiment also. So here, to simulate what happens at different latitudes as well as longitudes, actually you can see it in this video. Let us see. I'm just going to play this video. You will come to know yourself what is happening. I'll slower down the speed next time we play it. So you can see that what we have used is only the objects which I just showed you, right? A pencil and a ball. And yeah, let me slow it down and now play. Now look that there are two objects. One is more towards east and towards north. Okay. The other, which is at the center, you can see the bigger pipe. Okay. And it is towards west with respect to the pencil, the smaller object. Now, as the sun, that is our torch, is going to move from east to west above a particular meridian, what is going to happen? Let us see. Now look at this, at different latitudes and longitudes, what is going to happen? Let me pause it here. What we can see is at this particular moment for the pencil, the shadow is smallest or minimum. At the same time, the shadow of the rod is still large. Okay. And it is still towards west. So for that pipe, sun is still towards east. While for the pencil, the sun is overhead. So the sun is at crossing that meridian, right? So here we can actually teach the local time. Okay, the local time at the place. So while teaching time zones, we also teach in geography, we also teach local noon and standard noon, or local time and standard time. So in this, even when our clocks are showing us 12 noon, it is not necessary that on each and every longitude in India or anywhere on the globe, the time is going to be 12, right? The local noon occurs only when the sun comes overhead on that meridian where you are. And that is your local noon. Okay, so it is special for each and every longitude. This can be
Sorry,
seen
Sonal,
yeah?
we only have 5 minutes left,
Yes.
so
Yes, yes.
give
Okay.
time for discussion
Yeah,
also.
sure, sure.
Thanks.
And we can also see that at the same time, as the sun moves ahead, what we can see is the short shadow of that pipe is becoming shortest now, but it is not yet the shortest one, or it is not disappearing, which can simulate how seasons occur. Like as Samir mentioned, Uttarayan and Dakshinayan, the sun is when sun is towards south, the shadows even at local noon are casted towards north, and vice versa. So these are how you can simulate the motion or movements of the sun throughout the year. And yeah, so that was about DIY activities which can be done inside classroom at home to simulate movements of the sun. And Samir, can we, so shall we?
Yeah, so your slide brings us to the topic actually. The next thing we should be discussing. So
Yes.
we have some people from India and we have some from all over the world. So I think at this moment, although we have like so much to show, but what we would like is to hear your experiences. Do you already do this, like Aviva just mentioned, with some other name? Name is not so important, although. Or is there something that you would like to know from us or would like to share as a suggestion here? Please feel welcome to put up your, please raise your hand and then just put ahead your suggestions, comments, etc. On video and audio. We welcome anybody on stage. Just please use the reactions to raise your hand and then you're welcome to speak, please.
Let me stop sharing my screen.
Did you feel motivated, at least that you would like to do something similar in your place? Are you in a tropical country? Please come ahead. Tell us. If you're shy, please put it on chat. We welcome everyone here.
There's a hand raised by Amit.
Yeah, where did he go? Sorry.
Lowered.
Yes, asked to unmute. Please, Amit, quickly go ahead.
Yes, Alokji. Yes, we do perform this activity at our place also. I'm from Aurangabad, Maharashtra, and definitely it's a very fun activity for kids because they see the actual angle changing for the next if we place a particular object at 12 noon. So within 5 minutes, they can easily see a bit of angle changing. So that is what fascinates students, that yes, actually this is what it happens and this is how it goes around. And then we try to do the math behind it, and that is how they calculate. It is really a very fun activity, very rightly said. Students enjoy doing it, and they understand one thing, that okay, we are not studying math for the sake of math. It is being utilized practically in our life, and this is how we can use it in one of the
Lovely. Thank you. That's a very good point. Well made. Thanks, Amit. Anyone else? If there's any question to ask, feel free to do so as well. I'm sure we are not the best, people who might have explained everything perfectly in this short amount of time. So please feel free to ask questions as well.
I think someone mentioned Astrofanaticos. So I forgot the name. There's a collaborator that contributed.
Mauricio, yes.
Someone from Astrofanaticos was the one who translated the ZSD app in Spanish, I think. So we have had the translations are all from different contributors. So
amazing.
We have had,
Mauricio, yes, he just pointed out that. So yeah, that's another thing we are looking for, because Alok has done a great job at making the app, and even the web interface has been, has been updated recently. So another way you could contribute, even if you're not in a tropical country, is by helping us translate it to other languages. And it's a very simple way to do it. And if you get in touch with us, with Alok, maybe even directly, you'll be explained how to do it, and you can easily convert it into your own language, so that more people in your region could have a look at their own zero shadow days. Please feel free to reach out to us. Any other inputs are welcome. Sorry, I'm not able to monitor the chat and the and the participants list together. So guys, please keep a lookout. So this was not a really a hands-on kind of a workshop, but usually what we have is in these lovely teacher workshops and student workshops. That's a lot of fun, and we spent the whole day together, understanding the motions of the sky, the sun, what they have themselves observed at some point of time, but never realized that it's all connected, right, with geography and even geometry, etc. So that's something which really keeps us basically in touch with teachers all the time. These are the teacher workshops. So it has been really useful, not just as a popular activity with the public, but it's also been a real booster for us to reach teachers, because this is an activity which is directly related to the syllabus. Okay, so even if you're not an astronomy communicator but an educator, this could be useful. So we've converted so many teachers into astronomy communicators, which is an awesome thing, I think. So please feel free to look at that angle as well in your country. If there might be something like the IAU's national astronomy education contacts or something similar, right? Or the national outreach coordinators. if any of you are in that role, you can also look at that. But in general, this is an amazing activity, and I'm so happy that so many of our friends are also concurring with us. So to those friends who are in India, we welcome you to join hands. We are presenting to you in an international conference, but we've always been there for everyone to contact within the country, because there we already have a head start, and it's a very big large scale event. So the more hands we have in our country especially, the better. But of course, this is an international conference, and so I also appeal to all the friends here. If any of you have any suggestions or experiences to share, please feel free to send us those. Okay. And since the time is limited, I think we're coming to the end of the stipulated time, but we would love to keep talking to you on this particular topic. So let's do that. Let's catch up on email as well. If you don't have our emails, I'll just put it immediately. Sonal and Alok, please put in your emails as well. Mine is this.
Samir, thank you very, very much.
Thank you.
We've let you go on a few minutes because we're just waiting for the next workshop speaker to arrive. So we weren't too worried about you just telling us everything. It's really interesting to see what you do, as you said, which really rang true with me, this idea that it just doesn't cost much money to produce these things. And that really opens up lots of opportunities, not just in India, but in lots of places around the world. And the other idea, I think Sonal said it, about not doing maths and saying to the kids, this is maths, but doing something that's kind of astronomy, that's fun, that gets them outdoors, that gets them looking at things, and just putting the maths in there without them spotting it. And I think you will benefit from that as well. So I thank the three of you for participating and sharing all these ideas.